Hi guys, so in this video we're going to be learning about the product rule. So as we know, products are like the result when we multiply two different things, and in this instance we have two parts that contain x in them. So as we've been seeing recently, we would have components like 5 times x squared or 5 times x plus 1 to the power of 4, but none of these things have had more than one part of x. So in this case, there are two separate parts that contain x. You have the x cubed and you have the sine x. And the product rule is necessary if we want to be able to differentiate these two parts together. Okay, so let's take a look at this example over here. Let y equal x cubed times sine x. Find dy over dx. And dy over dx, as we know, is just the notation or way of expressing the derivative of y with respect to x. So before we can go further, we must know the equation for the product rule, as we know we're dealing with the product here of x cubed and sine x. So dy over dx, which as we just said is the derivative of y with respect to x, is equal to du over dx times v plus dv over dx times u. And you might be thinking at this point, what on earth are u and v? And what is du over dx and dv over dx? Well, u and v are just the parts of the function y, where u could equal x cubed and v equals sine x. So basically we just take the two parts with x in our function, and we assign one of them u and the other v. So at this point we just need to learn how to deal with the product of two different things containing x. We don't need to go further with 3 or 4, etc. So let's let u equal x cubed and v equal sine x. And now all we need to do is find the derivatives of both of these, because du over dx refers to derivative of x squared, which is our u in this case, and dv over dx refers to the derivative of v, or sine x in this case, which we've assigned to v. So let's just do that. So if u is x cubed, then du over dx, which is the derivative of function u with respect to x, is equal to, and in this case we can just use the power rule. So x cubed, we just drop the power down to the coefficient, and then we subtract 1 from the power, which gives us 3x squared. And then with the function v, differentiating it gives us dv over dx is equal to, and we know that sine x, we just have to memorize this one, but sine x becomes cos x when differentiated. So this would become cos x. All right, now we have everything we need in order to find dy over dx, which is ultimately what we're asked to find. We just need to plug it into the equation. So du over dx is first, so we just write 3x squared, multiplied by v, which is sine x, plus, and then dv over dx is cos x, and then we have to multiply that by u, which is x cubed. And that simplifies down to 3x squared sine x plus x cubed cos x. And then we can factor out the x squared from each term to get x squared times 3 sine x plus x cos x. And that's how we'd express the answer. Just try and simplify it as much as you can. All right, let's look at a more difficult problem. So if y equals 3x squared times 7x plus 4 to the power of 5, find dy over dx. So first thing we should notice is that we need both the product and chain rule in order to evaluate the derivative of the function y. So we need the product rule because we have two parts that contain x, so we have 3x squared and 7x plus 4 to the power of 5. But we need the chain rule because we have this expansion here that we don't want to have to expand because it would take a very, very long time, so the chain rule will make that very easy for us and straightforward. All right, so let's first set this up so that we have our u and v that we can then input into the product rule. So let's say that u is the first part, so 3x squared, and v is equal to 7x plus 4 to the power of 5. So finding du over dx, the derivative of u with respect to x, is fairly straightforward. 3x squared, you just drag the 2 down, multiply by the 3, gives you 6, and then decrease the power by 1 to give you 6x as the derivative. Now, dv over dx will require some more work, as we need the chain rule in this case. Oops, that's an ugly x. Let me write that again. Okay, so let's let the inside part be p. So p is equal to 7x plus 4. And so let's let the outside be q. So q is equal to p to the power of 5. Now, let's differentiate the two parts. So the derivative of p, so dp over dx, is just equal to 7, because the constant term gets reduced to 0, and then 7x just becomes 7. And then the derivative of q is dq over dx, which is equal to 5p to the power of 4. Now, all we have to do is multiply the two together to get the derivative of 7x plus 4 to the power of 5. So 7 times 5p to the power of 4 gives us 35p to the power of 4, which is equal to 35 times 7x plus 4 to the power of 4. So that's the derivative of v with respect to x. So we can write that over up here with dv over dx. And now let's erase the working below, just so we have more space to work with. All right, great. Now, all we have to do is input these values into the product rule. So first, let's put d over dx, which is 6x, and multiply that by v, which is 7x plus 4 to the power of 5. And then let's add that to the derivative of v with respect to x, which is 35 times 7x plus 4 to the power of 4. And let's multiply that by u, which is 3x squared. And now we just need to do a lot of simplification. So that just gives us 6x times 7x plus 4 to the power of 5 plus, and then 35 times 3x squared is 105x squared times 7x plus 4 to the power of 4. And now we can actually factor out quite a lot. We can factor out a 3, an x, and a 7x plus 4 to the power of 4, which gives us, let's do all that. So this is what we're factoring out, and we're left with on the other side. So let me just write a bigger bracket actually. We're left with 2 times 7x plus 4, because there's still one more remaining. And then 105 divided by 3 is actually 35, and you're left with an x as well, so plus 35x. And then now we just have to simplify this portion over here. So we get 3x times 7x plus 4 to the power of 5 multiplied by 14x plus 8 plus 35x. Just expanding the bracket over here, which gives us 3x times 7x plus 4 to the power of 5 times 49x plus 8 if we collect like terms. And that's our final answer. All simplified and grouped and factored. Finally, I just wanted to present a function where we can still use the product rule to find its derivative. So here we have y equals cosine of x over x squared. And in order to use the product rule, we need to make sure it's set up in a specific form. So the product rule relies on the fact that you have u times v as a function, so y equals u times v, or f of x is equal to u times v, where u and v are parts of the function that contain x in them. So like in one of our examples, I think u was x cubed and v was sine of x. So if we can express this function in that form, then we can use the product rule and go from there. So the function that we've written, y equals cosine of x over x squared, is the same as cosine of x times 1 over x squared. And essentially, we just need to make this here in the form as where there's no denominator so that we can have a product. So 1 over x squared is the same as writing x to the power of negative 2. So our new function can be written as y equals x to the power of negative 2 times cosine of x. And this function is in the form u times v. So we could use u as x to the power of negative 2 and v as cosine of x, and then differentiate them both and input them into our product rule equation to find the derivative of y. So I'm not going to go through that because it's the same steps as the previous problems, but it's just a handy way of taking a quotient and writing it as a product. However, later on you may come across functions which you are expected to differentiate, which have very complicated numerators and denominators, in which case the process of converting it into a form that's accessible for the product rule may become very tedious, long-winded, and generally just inefficient. So there is actually a separate rule for that known as the quotient rule, which we will cover in a future video, so not to worry about that. It's just another rule that you will have to know in order to differentiate a variety of functions. But until then, thank you so much for watching the video, and hopefully it helped out.